So as we start our semester 2 talk on the Algebra 2 F word here, I want to take a moment to go back to some of the things that we saw first semester before we start kind of putting some new things into it. General trinomials, okay? We're always going to check to see is there something in common or something like that. And actually, we're going to put step 0 up here. I don't know if you've ever seen a list that has step 0, but we're going to call it this because it needs to be checked out on every single one. We call it in here, we just call it the golden rule. You hear me talk about it before, but we'll kind of make note here in case somebody's new to this. And that is every time we do one of these, we need to look for a common factor. Now, there may be one, there may not be one. I'm not sure. But we always have to check that. So when we're looking in general at these, I'll look to see, does it have a number in front? Does it not? And so it can be anything on these from a diamond problem, which we did a lot of in first semester when there's no number in front of x squared. It's just, this is my multiply number, this is my add number. That's what we'll do here in a second. We can do guess and check, which we do more of when there's a number in front of x squared. I have a few of you that do that, but I have several of you that do what I'm going to put for my last option here, which I'm sure we will see at least once today, which is slide and divide, which basically takes a problem where there's a number, a coefficient, in front of my squared term and turns it into a diamond problem of sorts, just with an extra step. So for our first one here, though, I notice first that not all 3 of my terms have something in common. For me to be able to pull something out, they all have to have the same thing. So it's not like I can take x's out of the first 2, because there's no x's in the last one. So in a case like this, I'm looking for 2 numbers that multiply to get the number on the end, and add to get the number in the middle. And oftentimes, there are little clues even within that. Like, for instance, here, knowing that my multiply number is positive tells me that both my numbers are either positive or they're both negative, because negative times negative can be positive as well. So how do I find out? I look at the sign in the middle. It says negative, so I know they're both negative. And since they're the same sign, I need 2 numbers that multiply to 12 and add to 7, which would be 4 and 3. And I'm set. So that's not going to be too bad. A perfect square trinomial. Now, I still could do the exact same thing I did up here for this. What multiplies to 25 and adds to 10. But in general, if I see a perfect square as my last term, what I can do is say, okay, I'm multiplying to get 25. Well, 5 times 5 is 25. We'll get to our perfect squares here in a minute. And my sign in the middle is plus. Now, is it wrong if I do it this other way and I get 2 sets of parentheses instead? And I say, okay, well, I'm going to figure this out. What multiplies to 25 and adds to 10? Well, 5 and 5 do. That's fine. Okay, it doesn't have to be written with the square to be correct. If you would like to do it that way, you absolutely can, and we're okay with that. Here's where I'm going to jump in with the squares, though. Difference of squares. Now, we talked about this before. This is where we've got an a plus b, a minus b is what we call it, which is basically what do I square to get each term, and I put plus in the middle and minus in the middle of the other. And so we've also spoken before about the need to at least recognize what a perfect square is. If you know your perfect squares, at least to 10 maybe, I've got them here to 15, that would be more helpful. And I've also put them onto the sideboard, so you're going to kind of have a reference as we go along. Will those be there when we get to quizzes and tests? Maybe, maybe not. But here in this instance, okay, 4, I know I square 2 to get 4 and x to get x squared. And I know I square 3 to get 9. So that's my A and my B. So when I go to write this, I can't do it in one set of parentheses, one quantity like I did here, because the signs are going to be different. one's going to be 2x plus 3, and the other one's going to be 2x minus 3, and I'm done. And sometimes we may even get to a point that the only thing we can do is the golden rule, find what they have in common. I want to find the largest number that divides into both of these, which in this case would be 3. And I've even got to look at my exponents, okay, my variable terms, because if they have that in common, I just take the smaller of the two. So I can take out 3x, and then whatever I multiply that by to get each one back is what I'm going to put in the parentheses. So 3 times 2 is 6. And then I've got 1x, 1 plus 1. And you don't have to put the 1's on there, but it can be helpful. Would give me x squared. And then 3 times what gets me to 15? 5. I already have my 1x. So that's as far as I'm going to go. So those are some things that are still going to show up in what we're doing. But hopefully that from before we've got a little bit of background to it. So now on to some of the new things. So you'll notice down here, sum and difference of cubes. Unlike squares, we have a sum and a difference. You need to know your patterns. And as we start doing these, there's a little bit of a pattern within them, a little bit of a beat you almost be able to do. No, I will not be doing full-fledged songs with these, but it'll kind of let us see how this is going to work. So here's how these go. So if I have a sum of cubes, and again, knowing my cubes, let me flip this over. Knowing my cubes, so I recognize numbers when I see them, like 8 or 27, 64, and so on, is going to be helpful. Because what I'm going to do is I'm going to say, okay, what do I cube to get each one of these? And I even like jotting them down like we are here just to remind me, because then I follow the pattern. Okay. X and 2 are my terms that I'm going to use. The plus in the middle tells me how to start. X plus 2, okay. Square my first term, square the x. Switch signs, and what I mean is if I start with a plus here, this next sign is going to be a minus. So minus the product of those two, x times 2 is 2x, and then plus the square of my last term, 2 squared is 4. The nice thing about these, you'll never have to do more than one step with them. And it's going to be that same thing when I do a difference, except you'll notice the signs are switched. What do I cube to get 8? 2, let me get my cubes back up here. With my x, what do I cube to get 1? 1, not negative 1. Okay, we don't worry about signs, just numbers with these. And then I start. 2x, sign in the middle, so 2x minus 1. Square my first term. So let me show you where that comes from. My first term is 2x, and I'm going to square it. I'm squaring the 2, and I'm squaring the x. So that's where 4x squared comes from. Plus, because I changed my sign, the product of these two, 2x times 1 is 2x, and then plus my last term, 1 squared. So it's one of those that you're probably going to have the form right here as you're doing them the first few times. But as you start doing them, it's going to get easier. But again, it's about practice. If you don't practice, it's not going to go better. Okay? So as we get into kind of a mixture of these, always look for that common term first, our golden rule. And then depending on how many terms we have, which we just got done talking about going into that last quiz, that'll help us see what we're going to do. So for instance, on this first one, I always look first. Do they have something in common? No. So then I start and I'm like, okay, are there any special terms? Are there any squares or cubes or things? Now I should get a clue here. X to the third. Wonder if 27 is a cube. Oh, it is. So I jot down what I cubed to get each piece. And again, if for right now I need to look at the form up here to see how it goes, that's okay. So I'm like, okay, sum of cubes. The first one is a plus b, or in this case, x plus 3. Okay, I get that part. So then how does it go? square my first term, x squared. Change my sign. I started with plus, I go to minus. Multiply the two terms together, so 3 times x is 3x. And then plus my second term squared. 3 squared is 9. I'm done. So you're like, okay, this might not be awful. We'll see. So then you look at 2 and you're like, whoa, what is that? You haven't done anything with the fifth. Oh my gosh, I'm going to skip. No, don't skip it. Common. Okay, now this may be one where we need to grab a calculator. Because I started to looking at those, and I see they both have u's, so we're going to be able to pull a u out. And I also am looking at 16 and 250. I'm like, I might be able to take something out of there. So let's kind of play. And that's going to be the case with some of these. You may not know what to do right off the bat. You may have to play around a little bit before you get what you're looking for. So I'm like, okay, 16 and 250. And I always tell people, try to think of some bigger numbers that might go in. So like, let's say, like, I don't know, it's this. Ooh, that's not going to help me. Okay, does 16 go in? Okay, no. It's always worth a shot. What else goes into 16? 8 does. Does 8 go in? No. 4? No. 2? Something that goes into 16 go in? Okay, 2 does. So, I'm going to pull out a 2. I also notice they both have u's, but when we're looking at that, remember, it's always the smaller one I'm going to pull out. So I'm going to pull out 2u squared. So let's see what that leaves me with. So 16 divided by, why does it keep giving me y? 16 divided by 2 is 8. I have 2 u's, I need to get 5. I need 3 more. And then 250, let me scooch this over a little bit, divided by 2 is 125, and I already have both my u's. Now, before you circle this and say, woo, I'm good, always take a look what's left in the parentheses and see, is there anything else I can do? Especially if you're kind of working with your list, you're like, wait a minute. Wait, I see a cube. Is 8 a cube? Yes. Is 125 a cube? Yes. I need to break this down a little bit more. So I'm going to take each of my terms. What do I cube to get 8? 2 and u. What do I cube to get 125? 5. So let's see what this is going to look like. So I've already got this 2u squared on the outside. That's still going to be there. And now I'm going to follow my pattern for a difference, because there's minus in the middle, of cubes. So how's this work again? Okay, it's first minus second. I just used the sign that's in there. And then the pattern goes square my first term. So 2 squared is 4. U squared is u squared. Switch my sign so it goes to plus. Multiply my 2 terms together. And again, you don't deal with signs up here. That's in my pattern. So 10u. And then plus squaring my last term. 5 squared is 25. Okay, so just because there's a common term doesn't mean I'm going to be able to factor it. Sometimes it'll help me to be able to factor it. But it's one of the things I'm going to have to watch for. Now, we're going to bounce around here a little bit for a second, because I want to stick with the cube theme for a second. And then we will start to... Actually, no, let's do this. So I go on to 3. We'll stay in order here for a minute. So I look, and I'm like, anything dividing to 25 and 36? I try some things. No. But then I start looking at 25 and 36. I'm like, wait a minute. I've seen those numbers somewhere before. They're both perfect squares. You're like, but that isn't squared. That says to the 4th. Okay, here's what we're going to do. We're going to treat this like it's 25x squared minus 36. Like, how can you do that? because it's an even value, 2, 4. We can kind of look at it and deal with it the same way. So if it were this, I would say, okay, what do I square to get 25? 5. We're going to leave the x part alone for just a second. We have plus and minus. And then what do I square to get 36? 6. Now, if this were 25x squared, we would normally just do x and x. Because 5x times 5x is 25x squared. You're like, yeah, but this isn't. This is x to the 4th. So if 1 plus 1 is 2, what plus what's going to get me to 4? 2. So the only difference is, if it says x to the 4th, instead of just having x and x, I do x squared and x squared. But the pattern doesn't change. Okay, so that's one of the things we're going to have to notice a little bit. But if you've got to treat it like this and then change it into squares at the end, there's nothing wrong with that. Okay, we can do that. And the other twist that can get thrown in here, okay, I'm going to jump down to 8, and then we're going to jump back up to 5 here. So I look at 8, and I'm like, okay, well, wait a minute, that says cube, but 3's not in my cubes list, 10's not in my cubes list. What's going on? Do all 3 of those terms have anything in common? Okay, numbers, no, do they all have the same variable? Yeah, they all have an x. So what happens if I pull out an x? Well, 1 plus what gets me to 3? That'd be 2. And then here I've got a 3. 1 plus what gets me to 2? Okay. And then here, negative 10, and I already have an x, so I don't need another one. Now, sometimes that may be all you can do, but is that true in this case? No. Because now it just looks like a regular diamond problem that I could do. Okay, whenever there's 3 terms, I'm always going to look and see, okay, let's see if with a couple of clues I can find something that works. My multiply number is negative 10. Okay, if I multiply to a negative, I know I'm going to have one of each sign. I also know then that with one of each sign, the 2 numbers are going to be 3 apart, that I'm going to subtract them to get to 3. Well, with 10, I've only got 2 choices, 10 and 1, that doesn't subtract to 3, or 5 and 2. But which number goes in which place? This sign will tell me the bigger number's sign. So the 5 is going to be the plus, and the 2 is going to be there. So sometimes, once I take my common factor out, that's going to be what this looks like. And the only other one that we haven't really talked about yet before we get into a few more examples and some twists. Ooh, what happens if there's 4 terms? This is kind of crazy. Okay, if there's 4 terms, what we're going to do is we're going to group them into pairs. And what we're going to do is we're going to look at each separate pair to find what they have in common. So I'm going to kind of cover up this second one for a minute and say, okay, what do these first 2 terms have in common? Well, they both have x. Now, it's true, but always take the smaller one. And I actually see an exponent's my smallest one. So that'd be x squared. Okay, 2 plus what gets me to 3? 1. Here, I've already got both my x's, so I just need the negative 2. Now, that's all I can do with that for right now. So then I'm going to switch over, and I'm going to do that same thing to the second pair. But here's my goal. My goal is, when I pull out the common factor and I get the parentheses, that my parentheses end up being the same. If they're not, something ain't going right. So what can I pull out of these 2? Got to be something. 5. So now, if I pull out 5, wait a minute, 5 times what would get me to negative 5x? Ooh, that'd be negative x. That's not quite the same. So maybe I need to pull negative 5 out. Let's see if that works. Negative 5 times what gets me to negative 5x? I just need an x. And negative 5 times what gets me to positive 10? Negative times negative. Okay, the parentheses are the same. That's what I'm looking for. So when I go to write my final answer, the final answer is going to be my two greatest common factors, the stuff I pulled out, my leftovers. They're going to go together. And then whatever my common set of parentheses is. It's not squared. You just write it once. But you're going to have your two sets of parentheses that look like that. And that'll be true on any of these. So like if I do it again on 7, same idea. Pair them off. Look for the biggest thing that they have in common. Sometimes it may be a variable. Sometimes it may be a coefficient. Sometimes it may be both. So like here, x looks like the only thing they have in common. So I'm like, okay. So I got 1x. I need to get to 2. I got the x here. I just need the 5. So I know in my head now, okay, when I pull out my common term here, 2x plus 5 better be what's left or something ain't good. 10 and 25. I start playing with that. Okay, so that'd be 5. 5 goes into both of those. 5 times what gets me to 10? 2. 5 times what gets me to 25? 5. I got what I wanted. Okay, greatest common factors together. And my common pair together. Again, if that common pair doesn't come up common, you did something wrong with one of them. Okay, we need to go back and check that. Because otherwise we can get ourselves into quite a little bit of a dilemma here. Okay. Issues so far, besides the fact that it's new, which can be kind of frightening at times. Yet, okay. So as we flip over, I just wanted to kind of get one more reminder out there again. When you start to see some of these, they can look kind of strange. Like for instance, if I'm looking at number 10, okay, number 10, kind of weird. Remember, first thing always, does something divide into all the terms? And in this case, I hope it would be obvious since these both start with 7, that 7 will go into both. But if you're not sure, we can check. But I also notice they both have x's. So, I get that in there like that. And I go, okay, I already got the 7. I got 1x. I need to get to 3. That would leave me with 2. And once I get there, here I've already got my x. And we just saw in the calculator that 700 divided by 7 is 100. Now before I circle it, because it's good, I got the common factor out. Always look in the parentheses, especially if it's a squared or a cubed that's in there, and say, ooh, can I factor this? Ooh, wait a minute. Wait a minute, 100. Wait, I've seen that somewhere before today. Oh yeah, that's a perfect square. Oh, this is a difference of squares. What do I square to get x squared? X times x. What do I square to get 100? I don't remember. I look at my little list here. 10. And since it's a difference, it's plus and minus. Sometimes I may have to do that. And kind of keep working. Okay. So instead of going me crazy doing like a bajillion more of these, I actually want to do some on the worksheet with you. Because our worksheet is the day 1 factoring worksheet, which I'm going to flip up here in just a second. Okay. But if you want to, work some of these other ones on the notes, I can look at those and kind of help you with that, as well. So this is the actual homework sheet. Again, dating things is a good idea, just to make life a little easier on you. And so what we're going to do here, and like I said before, you've got to know yourself best. Some of you may have found out you needed to do some more practice after the first quiz. Some of you found out maybe you're just right on track. We'll see. But I'm kind of going to, I picked and chosen choose nice English Harty. On what we could do here, and again, I kind of got to remember back to my notes, depending on how many terms there are, what I'm going to do. So if there's 4 terms, we're going to look at this as far as grouping goes. Remembering, I take out the largest coefficient, if there is one, but 3 and 7, nothing divides into both. So it's just my variable term, the smallest exponent. So I need the 7. I have n squared. I need to get to 3, so I need one more. My next term, I need the 3, and I've already got the n squared, so that's as far as I need to go. Now when I get to the second one, I notice they both have negatives, so I'm probably going to have to pull out a negative. Now I need to find the largest number that probably is going to divide into 9 and 21, which is 3. Because again, I have a little bit of a clue here. 3 times what gets me to 21? 7, and I need the n. 3 times what gets me to 9? 3. And it's got to be plus, because otherwise it would change signs. They're the same. This is good. Because again, then my answer, don't stop, is my common factors, the leftover stuff on the outside, and then that common quantity, that common set of parentheses. So it's just kind of playing greatest common factor, greatest common factor, greatest common factor, and making sure that that works. So I go down a little further, and I look at number 9, let's say. Now, I see the cube. Now, normally that's going to tell me, ooh, it's going to be sum or difference of cubes. But I start looking at my cubes, and I'm like, wait a minute. 108's not on my list, neither is 256. What's going on? Oh, maybe, just maybe, something is going to divide into both of those, and then I'll end up with a cube. So I start playing around a little bit. And here's going to be the key with these. We don't want to get used to just trying to shoot for the low-hanging fruit here and go, well, 2 goes into both. And I pull out 2. Well, 2 issues. 1, 2 will still go into both of those. So I need to try something bigger. So let's see. Let's try 4 in both of them. Does something still go into 27 and 64? I don't think so. So let's try 4. 4 doesn't work, we'll try something else. So if I pull out a 4, again, the bigger the better. I get 27 with my x cubed, and I get 64 with that part. And now I take a look at what's in the parentheses, and I look at those numbers, and now I look at my cubes list. Hey, okay. Now I got something I can work with. So again, whatever I cube to get each of those, that's going to be my A and B. That's what I need to be able to plug into my form. And again, if you need to keep going back for the time being to pull the forms up, that's okay for right now. That's what they're there for. So I see the plus, so it's going to be sum. So first term plus second term. Then I'm going to square my first term, and again, it's the 3 and the x. So 3 squared is 9x squared. Change your sign. I started with plus. I go to minus here. And then I multiply them together. 3x times 4 is 12x. And then plus my second term squared. And I'm set. Am I going to have to pull out a common factor every single time with this? No. Okay, I always want to check, but that may not be the case each time. Sometimes it may be, as you kind of notice on number 12, I can kind of cheat here, that it's just going to be the 3x and the 4 right away. So really, the number 12 is answered already. That's kind of slick. But sometimes it will, sometimes it won't. But let the cube be your guide. Hey, I should be able to take something out where these are going to be perfect cubes. Okay, or if it's to the fourth, maybe it's something that's perfect squares. Let me see if I got something else in the back here that looks fun. Oh, I see a couple. Okay. I see 2 more back here to play with. So 15. Okay, I look at and I see the fourth and 1. I'm like, they have nothing in common to pull out. So is there anything I can do? Well, wait a minute. 9 and 1 are on my perfect squares list, but oh, yeah. That's like that one he was saying on the notes. I'm going to treat this like it's a squared term. So if that was 9v squared minus 1, that's a difference of squares. Okay, what do I square to get 9? 3. What do I square to get v squared? V. And then it's plus 1 minus 1. But I don't want squared. I want to the fourth. So when it's squared, it's 1 plus 1 is 2. But now it's 2 plus 2 is 4. That's the only difference between that and the squares. So if you see a 4, that's kind of your clue in the head. Hey, keep my perfect squares in mind when I'm doing this to try and make this a little easier. And then the last one I'm going to do is we're going to do a quick review to the past here. We haven't actually done a slide and divide problem for those of you that are going to be playing with this a bit. Now, I still want to check and see, is there something that goes into all of these? Because, I don't really want to play with slide and divide with numbers that big. So I'm like, what goes into 21? Well, 7 and 3. I know 7 doesn't go into 75, but I think 3, let's try that with actually putting the whole number in. Okay, 3, does 3 work on all of these? Yes, okay. So I can pull out a 3. Can I pull out an n? No, my last term doesn't have one. So if I divide all of these by 3, and I just did that here. Now, is this still going to be a whole heaping lot of fun? No, but it's a little bit better. Because now I want to be able to try and factor this. If you're comfortable with guess and check, that would probably be a little bit simpler here. But a lot of you have talked to me on, I'm not real good with my multiplication facts. I need some help on something like this. So this is where we go to slide and divide. So if you're going to go that route, remember, this is where, and I'm actually going to do it on a Post-it here to the side. If you're a slide and divider, just go ahead and do it on your paper, because I want to be able to show this 2 ways. That's why I'm going to do it on a Post-it here instead. So when I do the 7n squared plus 40n plus 25, we're going to swing that 7 down to the end. We're going to multiply it. Now 175, okay? I need to find 2 numbers that are going to multiply to 175 and add to 40. You're like, I'm not going to know that off the top of my head. Are you crazy? No, I'm not crazy. What I'm going to tell you is you're going to need to take your 175 and you're going to need to start playing with it. Now, again, there's going to be some ways to shorten this up. 175, I'm like, well, wait a minute. It ends in 5, so 5 should go into it. So let's try that first. And I'm going to jot down these pairs of numbers. And I take a look at that for a minute, and I go, multiplying to a positive, adding to a positive. Okay. So my 2 numbers need to add up to 40. Well, coincidence of coincidences. 5 plus 35 is 40. I got kind of fortunate. Now, does that mean that I'm done factoring this? I did my diamond. No. Because remember, it's called slide and divide. That number I slid down before, I'm going to divide in now. And if it goes in nice, 35 divided by 7 is 5. That's great. If it doesn't go in nice, and it's fully reduced, we just put it back at the start in front of the n. And then to finish it, I put 3 in front. Okay? So what I circled there, that's what my final answer would look like. Now, if you're a guess and checker, I'll just show you something that might make you feel a little bit better about that choice. easy part here, there's only one way I can get to 7n squared. 7n and n. There's no other way. And when it comes to 25, there's only two ways I can do that. 25 and 1 or 5 and 5. But if I want to multiply those together to get 40, I don't think 7 times 25 is getting me close. So I'm like, it's probably going to be 5 and 5. 5 and 35 is 40. Oh, okay, plus, plus. So either one of those is going to work. It just depends on where your skill level is, what you're more comfortable with. So as I'm going to keep barking over and over, do enough of these that you're comfortable. Because if you just throw this down and go, I don't like this, I didn't like it first semester, I'm not going to like it now, you're going to get yourself in trouble because the factoring's not going away. Okay, we got to tackle it. We got to take it face on. Tomorrow, there's just going to be a practice that we're going to keep doing these. There won't be as much notes. There's some more time to work in class, but you need to do some of these on your own. Okay? So we'll get you a little bit of time here to do